A warm welcome to you all to this wonderful session on applied hydraulics and pneumatics. So now we'll just move on to the session. Okay, just tell me what are the things which you observe when you see this onion harvester, which has been made by our students. So can you observe or can you identify the things which is related to our topic? Yes. Next, I'm just showing a truck with a lifted trailer. I think now you could have got an idea what is the thing which we are going to learn. The two common things which is shown in the figure. Yes, I think you are very much close to the thing which we are going to learn today. And the third one is an excavator. So I think you all now you all got an idea what we are going to learn today. What is the main motto or an objective of today's session? Yes, we are right. Today we will be learning about an actuator. So not an actuator, it's a kind of a linear actuator powered by an hydraulic system. So yes, today we will be learning about hydraulic linear actuators. Yes. So now we'll move on to the session. So at the end of the session, we'll be able to understand what is an actuator is and what are the types of an actuator and how they've been classified, and based on the classifications how they've been splitted up based on their construction and working principle. Yes. So in that we'll be learning detail about the various working principle and their cushioning mechanisms and their applications and the entire objective of getting a various kind of cylinders, hydraulic cylinders. Okay. So next, what is fluid power? So fluid power, when it terms like fluid power means it's a combination. I can just define it as a combination of three terms in related to force, that is generation, control and transmission. So that is a generation of force, controlling the force in terms of direction, and then transmission of force with the help of a pressurized fluid, but in a confined region, or we can say in a closed loop or closed circuit. That is what we define a fluid power is. It's a technology which deals with all these three criterias in a closed confined region with a pressurized fluid. So that is the term we term it as fluid power. So then what is an actuator? Next is, what is actuator? So actuator in general purpose of it's a kind of general purpose of controlling movements within a machines. Like there are kind of an actuators producing various motions and use different power sources. So distinguishing the differences between these motion controlling devices, this will help you to troubleshoot the parts, or even it could be able to refine the process within your machine. Like by definition we can say it's a kind of a machine which initiates movement after receiving a feedback device from your control signal. The entire functioning of this actuators will be totally depend on the feedback signal received, and also the motion is totally depend on the purpose of the machine which is been for which it has been implemented. Okay, so that is what it's been shown in your figure. So you're given energy or a signal as an input, you will extract if to the actuator, you will extract either the motion or a force as an output. Okay, so that is an application of your actuators. So the main actuator is, what are the types of an actuator? What are some other devices? For example, we can say few of the devices like electric motors, stepper motors, or hydraulic cylinders. These are all the devices of actuators. So what actually the electric motors do? Like any part or piece of your equipment or an appliances which translates an electric energy into motion, such as like they found in we can see in ventilation fans, blenders, refrigerators. So at least all these contains at least one actuators. Even we can say electric car as an electric actuators. So then we could say it's the stepper motor. Stepper motor, these actuators are like best known for receiving digital signals. Like what actually do is they receive signals or pulses and convert them into a mechanical motions. They like you can see often stepper motors in your robo arms, tools, and all those automated cutting equipments. Okay, so then another device of an actuator is we will call a hydraulic cylinder as an actuator. It's a kind of a device that operates using a tube, piston, and a rod. Okay, so the vehicle operate using an hydraulic motion, such as like we can say in the initial stage. I have in the initial slide itself, I have shown you bulldozers, backhoes, and excavators. So these are all the some devices with actuators. Okay, so generally we classify base actuators based on the power sources, means they are electric motors and stepper motors and hydraulic cylinders. So if we classify actuators based on type of motion, is it's linear and rotary. Okay, so in linear and rotary, so what are linear actuators? So by the name implies, like you can say it's a device that produce movement within a straight path. So they can either be mechanical or electrical. They are mostly seen in hydraulic or pneumatic devices. So that is what it's been stated here. What actually is an any machine, what actually a linear actuator is, and in any machine, equipment, or a gadget that requires some form of straight motions. Like typically we call it as linear actuators. Like in simple, we can define linear actuator like there is a nut, cover, and a sliding tube. Okay, the sliding tube provides the space for the motion, whereas the nut and the cover provide the interlocking movement that keeps the actuator in a straight path actually. So the other complex linear actuators will have an additional parts, obviously, but the system mentioned above is the foundation of the straight movement. Like we'll have a linear actuators. Okay, so that is what we define it as linear actuation. For rotary actuations, like many rotary actuators are electrically powered. So some are like we can say you can find rotary actuators in windshield wipers, electric fans, and a and transport equipments in manufacturing, like a kind of a metal handling equipments we can say in any of the manufacturing industries. Okay, so now we have generally discussed about actuators and types of actuators and its classification based on the motion and the power source. So, okay, so now we can say based on the power sources, we classify actuators in two different types: hydraulic actuators and pneumatic actuators. Okay, and even we can say we can classify them as mechanical and electrical actuators. Okay, so the source of energy we use, the like what actually is hydraulic actuators. Hydraulic actuators actuate or operate by the use of fluid filled cylinder with the piston suspended at the end center. Commonly in hydraulic actuators produce linear movements and a spring is attached to one end as a part of your return motion. These actuators are widely seen in your exercise equipment such as steppers or car transport carriers. Okay. So now we like then in general we can even I can explain you what is a pneumatic actuator is. The pneumatic actuator you can generally see in your bus brakes, exercise machines, vane motors, and your pressure sensors. Even in your pneumatic mailing systems, you can actually see a kind of pneumatic actuator systems. Okay, so generally, before going to the types of hydraulic cylinders, I just want you to convey how you select an actuators. Like actually, we define four different sources. That is based on the power, based on four main classes. We find out we'll select an actuator. They are like based on the power source. So then second is a required movement. Required movement in the sense that like the range of movement that you need for your equipment. Is it really a linear or rotary or integration of both? Okay. Next is the precision. Some actuators are more precise than others. For example, air brakes are created through pneumatic actuator because air pressure is known to be efficient in the start and the stop of the movements. So that's what is shown. Okay. Next is like safety and environmental concerns. These are all the factors we need to consider before selecting an actuators. Okay. So what are the hydraulic linear actuators? So that is what the main thing which we'll be learning in this session. Hydraulic linear actuators. So as the name implies, you can say it provides motion in a straight line. As you can see in your animated image, it has been shown here. The total movement is a finite amount, like entire. It's all been determined by the construction of the unit. They are usually referred to as a cylinder, ram, and jacks. Okay, so then the function of your hydraulic cylinder is to convert your hydraulic power into a linear mechanical forces or a motion, we can say. So the hydraulic cylinder is extended as is shown, like either it can extend or retract a piston rod to provide a push or a pull force to drive the external load along in a straight line path, as you see. So continuous angular movement is achieved by, even you can achieve angular movement by rotary actuators, or if we can say it is as generally hydraulic motors also we can say. Okay, so that is what's all about an actuator is. So we classify now in the session we'll be discussing about single acting cylinders, double acting cylinder, telescopic cylinders, and tandem cylinders. Okay, so single acting cylinder. Now whatever the image which I shown the first, this is a single acting cylinder and this one is a double acting cylinder, as you all know. So single acting cylinder, like as you, it's the simplest kind. It consists of a piston inside a cylinder called piston inside a cylindrical housing called a barrel. One end of the piston, like you will have a rod which can reciprocate. At the opposite end, there is a port for the entrance and the exit of an oil. And a single acting cylinder, like it produces, like actually is like it produces force in one direction by your hydraulic pressure acting on the piston. So like what actually is, if single acting cylinders can exert force in an extended direction alone, like from this, like it can extend, produce force in a one direction, which means like it can exert force in an extending direction alone. The retraction, the return of the piston is not done hydraulically. Like the retraction is done either by your gravity or by your string. Okay, so based on that we will classify single acting cylinder in two types, that is gravity return single acting cylinder and spring return single acting cylinder. The image which we have shown here is a representation of your spring return single acting cylinders. Okay, so spring return and gravity. So this is an animation. So when your force exerts, so when you apply a fluid, pressurized fluid into your single acting cylinder, the piston rod starts exerting. So and then after reaching the maximum point, like here you have a vent support. So the fluid exits through this vent. So because of which you will get a pressure drop inside this area, so that your spring extends. So which makes your retraction in an automatic way. So as it's stated in the second point, that is like a cylinder produce force only in one direction, the retraction has been done, it's not been done with hydraulical force, it's done with the spring force exerted. Okay, so as I stated, like we are having two different types of single acting cylinders. One is gravity return single acting cylinder and another is a spring return single acting cylinder. So gravity return single acting cylinder, in this type we have two, in this we will have two different types. It's a push type and a pull type. So what actually happens is the cylinder extends to lift a weight against the force of gravity by applying a oil pressure at the blank end. Okay, so the oil is passed through the blank end port or a pressure port, we can say. So the rod end of the port or the vent is which has been open to the atmosphere, so the air can flow freely in and out of the rod end of the cylinder. So to retract the cylinder, what actually is, the pressure has been to retract the cylinder, the pressure is simply removed by connecting the piston end to the tank. Okay, so which allows the weight of the load to push the fluid out of the cylinder, and like whatever the fluid which has been pushed out will be sent back to the tank, which automatically makes your cylinder to retract. In pull type, what actually happens is the pull type cylinder, gravity cylinder, the cylinder lifts the weight by retracting. The blank end port is a pressure port, and the blind end port is the vent port. Okay, so the blind end port is the vent port. The cylinder automatically extends whenever the pressure port is connected to your tank. So what actually is like pressure port, the other way around, when you connect this pressure port to your tank, the pressure in this area, pressure inside the piston area will get reduced, because of which your piston extension takes place. So in the same way, we are making, instead of this giving a weight, that is your gravity or a weight support, we are performing this extension and retraction with the help of spring support, spring loaded. So that is the main difference. Okay, so the next one is like double acting cylinder. Double acting cylinder, like it is with the piston rod on the one side, shows an operation like in this we have two different types of double acting cylinders: piston rod with one side and double acting cylinder with piston rod on both sides. To extend the cylinder, what actually happens is, to extend the cylinder, just if you see this animation image, you can even easily understand. If you to extend the cylinder, the pump flow is sent to the blank end of the port. Okay, that is what, for extension we are sending blank end of the port, as the fluid from the rod end of the port return to the reservoir. Okay, to retract the cylinder, the pump flow is sent to the rod end of the port, and fluid from the blank end of the port return to the tank. So this is how it has a two different ports. So for extension and retraction, we are just switching over the function. Okay, so that is what happens in your double acting cylinder. Okay, so this is what shown, double acting cylinder. This is the type double acting cylinder with the piston rod in one side. Okay, so double acting cylinder with piston on, like actually you can see it is having a piston rod only on one side, that is your fluid pump. It got extends, like you are supplying a pressurized fluid in the pump in this piston end. So what actually happens is your extension stroke happens. So after reaching the extension stroke, like your during this extension stroke, your return flow will be sent to your tank. So when you want to retract, or you want to go for perform a return stroke, means you just switch over it. Your pump flow will be in this point, and your return flow will be at the piston end. So that you just switching over the ports, so that we can perform extension and retraction in the same. Okay, so now we'll be seeing about piston double acting cylinder with piston rod on both sides. So double acting cylinder with piston rod, like, is a cylinder with the rod extension in the both ends. Okay, like what I say is like this can be like double acting cylinders. What is the main objective is, like, it can able to withstand higher side loads, because they have an extra bearings, like one on each rod. Okay, so we have an extra bearing so that it can able to withstand. The main objective is like these double acting cylinders with piston on both sides is being developed for withstanding and higher loads, so that the cylinder it can able to like application where they can both ends of the cylinder. Okay, so like they were making your cylinder, it been more productive, we can say. So this is the port you have. So when you like like double acting cylinder with piston port and the extended rod port. So you just we are these pressure drop points, we are this is an inlet we are giving. So by extension of your by extension, like, we are just giving a supply to this rod end. So your cylinder is piston rod extends, and the pressure due to the since your rod end is being connected to the reservoir tank. So the way it's a continuous closed loop of cycle, it performs your extension and retractions operation. So Next we'll be discussing about we'll see about your tandem cylinder. So the tandem cylinder, like it consists of two or more cylinder arrangements. Like as I see, as I you can see in this animated image, like it consists of two or more cylinders arranged one behind the other, but designed as a single unit. Okay, this type of actuations you can use to require two or more independent system. For example, we can say power operated flight control system in naval aircrafts. So they'll use a tandem cylinder, tandem hydraulic cylinders only. Like the flow of a fluid to and from the two chambers of the tandem cylinder is provided with two independent cylinders, hydraulic systems, and it's been controlled by your two sliding spool directions, like it's been shown here. In some applications, these control valves and the actuating cylinders are two different separate units. In some units, the piston of the two sliding spools are machined on one common shaft. Like in other application, the valves and actuators has been directly connected in one compact unit. So that is what your tandem actuator is like used for application. Like you have when you have a large amount of force required for small diameter cylinders, like the main when you have a large when you require when you are in need of a large amount of force in a small diameter of a cylinder, we can prefer tandem cylinders. The pressure applied on both the pistons resulting in increased force because of the larger area. So the drawback of the cylinder, it's like must be longer than the standard cylinder to achieve a equal speed, because of like your flow must go to the piston. So that is the main drawback we will face when we use tandem cylinders. Okay, like it can be used in amount of where you require large amount of force. So and then now we come for our next topic, that is your telescopic cylinder. So telescopic cylinder, like actually like when you see telescopic cylinders, we can use when you have a long stroke length and a short retracted length as required. Like the telescopic cylinders extends in stages. Like each stage consists of a sleeve. Okay, each stage consists of a sleeve that fits inside the previous stage. So like one application for this type of cylinder is rising a dump truck bed. Okay, so this is the telescopic cylinders are available in both, like you have a single acting and double acting models. They're most expensive actually than standard cylinders because of this complex constructions. They've been considered as more expensive. They generally consist of a nest of tubes, like you can see in this animated image, and operate on a displacement principle. The tubes are supported by the bearing rings. The innermost set of which have grooves or channels which allows your fluid to flow. The front bearing assembly on each section includes your seals and wing wiper rings. The stop rings which limits the movement of each section, like you will have a stop rings which limits the movement of the each section of your telescopic part, and thus preventing a separation. When the cylinder extends, as the section moves together until the outer section is prevented from the further extension by its top ring, the remaining sections continue outstroking until the second outermost section reaches the limit of the stroke. This actually is like this process continues until all the sections will be extended, the innermost one being the last of all. So that is what the main function of your telescopic cylinder. So what actually is like it start extends it extends in stage by stage. Like you have a sleeves, so it consists of a nest of tubes, and actually like when you have a sleeve, like when cylinder will start extending together until like end of the session is been done. Okay, so that is your objective of main purpose of your telescopic cylinder. So then now we go for our cushioning mechanism. So due to this, what actually cushioning mechanism? What is the main purpose of your cushioning mechanism? Is like due to the inertial forces. of moving parts at the end of the piston travel, the piston will hit the cylinder head at the full speed. Like if you see this image, so like the piston will hit the cylinder head at the full speed. To overcome this, like what actually happens is this will cause damage, like because of this impact it will cause damage to your piston end. So what actually do is we do is to overcome this. So like we provided an arrangement by which an hydraulic cylinder can slowly retracted or cushioned during the last portion of the cylinder stroke. That is what actually happens. Like what actually happens is during the return stroke, like we'll just control the pressure and we'll just release. Like here we'll have a check valve, so through which your pressurized fluid will get released. So what actually happens is this will act as a cushioning system. So like the last portion of the stroke, the oil has an exhaust through adjustable opening. Like you will have an adjustable opening. So this remain the fluid exists through your cushion valve. So what actually happens is your fluid will exit out. So through this cushioning valve, so which makes your retraction stroke at the end of the retraction stroke when your piston is about to hit in this space. So the entire force, the retraction, the force has been entirely controlled. So which actually what actually happens is it actually controls, like your it actually saves the life or controls the damage caused during your retraction stroke. Okay, so this is all about your cushioning mechanism. So the summary is like we discussed about various types of fluid power systems, and then we defined what is fluid power system. That is, it is a tool or a technology which connects generation of forces, transmission of forces, and controlling of forces in terms of using when we use a pressurized fluid. So what is the condition under a closed region? So that is what a fluid power system we define. So which directly implies that it's about all about your hydraulic cylinders. So where it will generate force, it will control the forces, and it will transmit the force, and also in a confined region with the help of pressurized fluids. So next we have discussed about various types of linear hydraulic actuators. So what is linear actuators is what actually an actuator is. It's a kind of a machine which performs or a specific movement. Okay, so that is what we have defined based on the requirement we have defined. And then finally we have discussed about various types of hydraulic cylinders, linear hydraulic actuators. So what are the linear hydraulic actuators? A single acting cylinder, double acting cylinder, and a tandem, telescopic, and rodless. So we have discussed the entire working principle and their constructional features. So special characteristics we have discussed. So and then finally we have come to the cushioning mechanisms. So what is the need of the cushioning mechanism and which way it helps for improving the life of your actuators? So what is the principle behind that? So all these things we have discussed in this session. I hope this session will give you a clear idea about whatever the topics we have discussed, like entire linear hydraulic actuators. Mm, thank you. Thanks for listening the session. Have a nice day. Thank you.